Ever found yourself wondering about the fascinating world of chemistry, specifically about precipitation and adsorption? Today we're going to dip our toes into this intriguing topic. Adsorption, a surface phenomenon where molecules accumulate on a surface, rather than in the volume of a solution, may sound complex, but it's truly fascinating. And within this area, two kinds of precipitation occur: bulk and surface. Each has its own unique characteristics and roles to play. To understand this better, we need to delve into the two types of precipitation: bulk and surface. First up, we have bulk precipitation. But what exactly is it? Well, imagine a solution that has so many solute particles it can't hold anymore. This supersaturated solution is a ticking time bomb, waiting for the right trigger to release excess particles. And when it does, we see bulk precipitation. So, what happens during bulk precipitation? In simple terms, it occurs when the entire volume of the solution gets involved in the process. The solute particles, unable to remain dissolved, start to aggregate and form visible particles or crystals. This phenomenon has some fascinating implications. Consider the formation of crystals. When bulk precipitation occurs, the resulting crystals can be quite large, which is an interesting feature. This is because the precipitation process happens throughout the entire solution, giving the crystals plenty of space to grow. And there's another point to consider. Bulk precipitation is not just a random event. It's a carefully orchestrated dance, governed by the laws of thermodynamics and kinetics. The rate at which the solute particles come together can influence the size and shape of the crystals formed. That was quite a dive into bulk precipitation, wasn't it? Now let's contrast this with surface precipitation. Now onto surface precipitation. It's quite different from bulk precipitation, but how? Surface precipitation is all about the interaction between the adsorbate and the surface of the adsorbent. It's a fascinating phenomenon where the precipitate forms only on the surface. Unlike bulk precipitation, where the precipitate is distributed throughout the solution, in surface precipitation, it is confined to the surface of the adsorbent. This selective process occurs when the adsorbent's surface has a high affinity for the adsorbate, attracting and holding it at the surface. The result? The formation of a film or layer on the surface. This layer can have significant implications. For instance, it can change the physical and chemical properties of the adsorbent's surface. It might alter how the surface interacts with other substances, or even change the surface's appearance. So, you see, surface precipitation is a unique occurrence in the realm of adsorption. It's intriguing to observe how the same process of precipitation can exhibit two different behaviors based on where it occurs. Interesting, isn't it? The same process of precipitation, but two distinct ways of occurring. So, what sets bulk and surface precipitation apart? Let's recap. Bulk precipitation happens within the solution, leading to the formation of crystals, while surface precipitation occurs on the adsorbent surface, resulting in a film. The location of these processes isn't their only difference. They also have distinct impacts on both the solution and the adsorbent. And there you have it. A simple breakdown of the differences between bulk and surface precipitation in adsorption. Remember, understanding these concepts is a key step in mastering the world of chemistry. Alright, we've come to the end of today's episode on bulk versus surface precipitation in adsorption. We've delved into the intriguing science behind these two phenomena, how they occur, and their distinguishable characteristics. If you found this fascinating, we urge you to dive deeper into the world of adsorption. It's a field full of captivating concepts and processes that are waiting to be discovered. Don't forget to subscribe to Aminulchem Innovation for more insightful and exciting content, and as always, thank you for tuning in, and we'll see you in the next video.